1-7, the distributive property. Our objective for this lesson is to use the distributive property to simplify expressions. And our essential understanding is that we can use the distributive property to simplify the product of a number and a sum or difference. So hopefully you've seen the distributive property before and are okay with kind of how it works. So basically, to solve problems in mathematics, it is often useful to rewrite expressions in similar forms. We can use all the different properties of real numbers that we've talked about so far in order to help us with that. And one that we can use often is called the distributive property, illustrated by the area model below. Okay, so if we look at these two graphs, the first one we have 8 times x plus 5. And in the second model, we have 8x and 8 times 5. If we're finding area, which is, of course, length times width, we can see that the shapes are pretty much the same shape, the same size, except they're broken up a little bit differently. In one, we have the whole thing together, and in the second one, they're broken up. So that's kind of how the distributive property works, is we can think about multiplication as, or we can think about distribution as a multiplication across a sum or a difference. Okay, so if we look at the distributive property in these four expressions right here, we can see that we can distribute the a to both the b and to the c, okay, to give me my new expression of ab plus ac. Okay, we can also use the commutative property to write these in a different order and put the term in the back instead of the front. Most of the time, we're going to see it in the front like that, but doesn't mean it has to be there, right? We can always put it in the back if we needed to. And our process is going to be the same. We're going to take b times a and then c times a to give me ba and ca. So we're going to take this thing that's outside of the sum or difference and distribute it and give it to both of the terms inside. Okay? Works the same with subtraction, is we can take the a, multiply it by the b, take the a, multiply it by the c to give me ab minus ac. Okay? And then the same one here. We can multiply both of those to give me ba minus bc. Okay? And here are my examples with numbers. We can see that 4 times 20 plus 6, of course, is 4 times 26, but we can also take it as 4 times 20 plus 4 times 6, and that will give us the same answer. So, let's try some problems. Problem 1, simplifying expressions. What is the simplified form of each expression? So we're going to use the distributive property. And the way you recognize that is that you're always going to see parentheses, and we're going to see something multiplied by two things inside the parentheses, usually with a sum or a difference. So we're going to take this 3 and pass it along to both of those. Let's take this nice and slow, and we're going to get 3 times x plus the 3 times 8, which of course we can simplify that to give me 3x plus 24. Okay. Part B works the same way, is we are going to multiply both of these to the -7. So be careful with the signs. Let's take this one slow as well. So we're going to get 5b times -7 minus 4 times -7. Okay? So this one is a little more confusing because the signs are so different. Okay? So we're going to multiply these two together, the numbers together. So that's positive 5 times a -7. The signs are different, so it's going to be negative. So that's a negative 35b. And then that's a -4 times a -7, right? If we wanted to, let's go back for a second. If we wanted to, -35b. If we wanted to, we could rewrite this as, right, subtraction means adding the opposite. So it's -4 times -7, which gives me a positive 28. Okay? Let's try a few got it problems. Okay? So with these, again, just be careful of the signs. First one's nice and simple. Distribute to 5, so we get 5x plus 35. Here, the second one, we're going to get 12 times 3 to give me 36 minus 12 times 1 over 6 is the same thing as 12 over 1 times 1 over 6, or 12 divided by 6, which is going to be 2. Okay, make sure you keep the negative sign because of the negative sign right there. Again, with decimals, no problem. It's just 3 times 0.4 is going to give me 1.2 plus 1.1 times 3 is going to give me 3.3, 3.36. The last one, of course, we have a variable out here, okay, so it's a little harder, but shouldn't be that bad. Just be careful of the sign. However, right, we have 2y times a negative y, so that's going to be a negative 2. Y times y is going to give me y squared, right? When you multiply two variables together, we add the exponent. So we're going to add 1y there to 1y there, and we're going to get y squared. Okay? If that was a little confusing, we're going to go over more with combining variables a little bit later. Okay? And then negative 1 times negative y is going to be a plus y. Negative times a negative gives me y positive. Okay? All right, so recall that a fraction bar may act as a grouping symbol. A fraction bar indicates division. Any fraction, a over b, can also be written as a times 1 over b. And we can use this fact and the distributive property to write some fractions as sums or differences, like this. So what sum or difference is equivalent to 7x plus 2 all over 5? Well, got to remember what that expression means. It means we're taking both the 7x and the 2 and we're dividing them by 5. Normally, we would put the stuff together first before we did the division, but we can't add those together. So we could just write them separately as 7x over 5 plus 2 over 5. But we want to use, well, that's where we're going to go. But let's use the distributive property to show that. Right? So we can use the property that we just talked about to say that this expression right here is going to be equivalent to 1/5 times 7x plus 2. Okay? Now I can distribute that 1/5 to give me 7x over 5 plus 2 over 5. Okay? And then, of course, if I wanted to put them back together, now they have a common denominator, I could do that to get back to where I started. Okay? So let's look at a couple of more examples of that, because that one might have been a little confusing. So we'll look at these, all right, and we're just going to separate these. We can think of this as 1/3 times 4x minus 16 to give me 4x over 3 minus 16 over 3. And then if you can simplify, you should. We can't here. Okay. I can do this all in one step by just saying this is going to be 11 over 6 plus 3x over 6. Now with this one, we should definitely simplify the 3x over 6 into 1/2 or just x over 2. Right? There's a 1 in front of that x. You don't have to write it to see it. Okay? So now we got 15 over 12, which is 5 over 4, plus 6 over 12, which is 1/2. And again, with part D, that's 1/2, 4 over 8, minus 2 over 8, which is 1/4. So that's x over 4. Okay? Good. Next, multiplication property of -1 states that -1 times anything is the opposite of that thing, negative x. So -1 times x is negative x. Okay? So to simplify an expression that looks like this, with that negative out front, all we're doing is rewriting it with a -1 out front and then distributing that -1 to the expression. So if we have a expression that looks like that, I can think of it as negative 1 times 2y minus 3x. Okay? And then distribute that negative 1 to both of those terms to give me negative 2y. Negative times a negative turns into a positive 3x, which is C. Okay? Let's look at some more problems with multiplication with negative 1. So we're going to distribute. We're just going to pass out that negative. We're going to multiply, right? We're going to take negative 1 times a plus 5. And I can do this quickly by making negative a minus 5. Okay. Negative times a negative in part B gives me a positive x minus a 31. Negative 4x plus 12. And negative 6m positive 9n. Oops. Okay. Now, we can use the distributive property to make calculations easier to do with mental math. That means without a calculator. Some numbers can be thought of as simple sums and differences. So there are some tests that you will take, like part of the PART test, the SATs when you finally get there, the PSATs, all right, that will not let you use a calculator. Okay, so it is a good idea to be able to do some mental math and to know how we can use the distributive property to make it easier for ourselves. So, deli sandwiches cost $4.95. What's the total cost of 8 sandwiches? Use mental math. Well, it's kind of hard to go 8 times $4.95 in my head. I don't want to do that. But what if I said, well, can I say 8 times 5 is about the answer and maybe subtract off those 5 cents? That will be the way to do this with mental math, because we should know that 8 times 5 is 40 bucks. Okay? 8 times 0.05, we just move that decimal, okay, is going to be 40 cents. Okay? So $40 minus 40 cents gives me $39.40. And we were able to do this quickly with mental math. Let's look at another one. Our Gata problem. Julia commutes to work on a train 4 times a week. Round trip ticket costs $7.95. Well, right, we don't want to go 4 times 7, 4 times 7, 25. What I would rather do is say 4 times $7 plus 25 cents. Okay? So 4 times 7 is going to be 28 bucks plus, if I can think of quarters, right? 4 quarters, 4 times 0.25 is $1. So this is going to be $29 for her round trip ticket. Okay? So our next essential understanding is that we can simplify algebraic expressions by combining the parts of the expression that are alike. Okay? And we are going to use this technique a lot. So in an algebraic expression, we have a couple of vocabulary words that you need to know what they mean. The first is a term, and that is a number, a variable, or the product of a number and one or more variables. So that covers a lot of things. A number, a variable, or the product of a number and a bunch of variables. And product could also mean division, right? Because dividing by 3 is just like multiplying by fractions. Okay, so this is all one term. The one thing you never see in a term, a single term, is going to be addition or subtraction, right? It doesn't say addition or subtraction, it says product. Okay, so we can only have multiplication or division inside of one term. If we have addition, that's fine. It's just this is 2 separate terms. Okay? A constant is a term that has no variable, just a number. The coefficient is the numerical factor of the term. So this one would be 2 over 3. The coefficient there would be 3, right? It's just whatever number happens to be in front of my different terms. Okay? Rewrite expressions as sums to identify this part of an expression. Okay, so let's look at that. So let's look at our first expression right there. So in the first one, 6a squared, the 6 is the coefficient. In the second part, the negative 5 is the coefficient. In the third one, the 3 is the coefficient. And the negative 12 is our constant term. All of these are my different terms. So this expression happens to have 4 terms, right? Those don't count as 3 separate, right? They're all together. They're all one term. Okay? What we're looking for is like terms. Like terms have the same variable factors. To identify like terms, compare the variable factors of the terms as shown below. Look at the variables. A in the first one, A in the second one. They are like terms, yes. Okay? It doesn't matter that the coefficients are different, and in fact, we can combine them. Okay? But the variable terms, the variable factors have to be exactly the same. 4x squared, 12x squared. Both of them are x squared. They are like terms. However, 6ab, negative 2a. One has an ab, one has an a. Those are not like terms. Okay? We cannot combine them. And look carefully at these two. Xy squared, x squared y. Those have the same letters, but they are not exactly the same. One has 1x, 2y's. The other one has 2x's, 1y. They are not like terms. Okay, so we cannot combine them. Okay. So an algebraic expression is in simplest form if it has no like terms or no parentheses. This is not simplified. I have to distribute. This is simplified. It has no parentheses, and I can't, those are not like terms. One has an x, one does not. So we can use the distributive property to help us combine like terms. Think of the distributive property as adding those two and multiplying it by a, and then doing inside the parentheses. So the way we should kind of know that this is going to be 10x squared when we add these together, but let's see exactly what is happening. So what's happening is that we're using the distributive property to say that we can say 8 plus 2 times x squared. Well, is this the same expression as this? Sure it is, because I can distribute the 8 and the 2 to x squared to go back to my original expression. But what I really want to do is now add the 8 and the 2 together to give me 10 times my x squared to get my simplified expression. Okay? And that's what we're going to do. We're really not going to do this step that often, but it is important to know that this is how the distributive property actually works. Okay? Let's look at part B, and let's take this really slowly. Okay? And we could, of course, rearrange this with the commutative property so that the things we want to add are right next to each other. Use the distributive property to separate, to separate everything the way we did in part A. But let's just take a look at this. And we have 5x. Make sure you're careful with the signs. So we have a 5x and a minus 3x. That minus 3x is part of the 3. And if it helps, we can rewrite this as just a sum in order to be very clear about this point. Okay? So this is a minus 3x. This is a 5x. When I combine them, I get 2x. That has a y. Nothing else has a y, so it can't go with anything. And then the negative 3 and the 4 add together to give me 1. Okay? Let's do a few got it problems. What is the simplified form of each expression? So we have a 3y minus a 1y. If you don't see it there, remember it's a 1, so that's going to be 2y. look carefully. Are those the same? Yes, they are. So we have negative 7 minus 5. Remember, that's a negative 7 plus a negative 5. So that's going to be a negative 12. And the variables do not change, right? Because we are just pulling them out with the distributive property. We're actually factoring those two out and then combining the coefficients. Okay? So these variables do not combine, that we are not multiplying them by anything. Okay? That one is not like the other two. So we can say that this is 8y to the third z minus 6yz to the third. You cannot put those two together anymore because they are not like terms. Can we simplify 8x squared minus 2x to the fourth minus 2x plus 2 plus xy any further? Not with what we know right now, right? Because look, x squared, x to the fourth, x, 2, xy. All terms that are not the same. Okay? In the future, maybe we can try to factor that a little bit and simplify it that way, but we cannot combine any like terms because they don't have any. Okay? So let's make sure we got everything here. We can use the distributive property, whether the number is in the back or in the front. If there's a negative in the front, we're just going to multiply each term by negative 1. Rewrite each expression. We're going to combine the like terms. The first one doesn't have any. And the next one doesn't have it either. Maybe just rewrite it as a sum. It just means negative 8x squared plus 3x, xy plus negative 9x plus negative 3. I guess that's what they were going for in that problem. Tell whether they're like terms. Those two are not. Vocabulary. Does each equation demonstrate the distributive property? That does. That does not. That is not the distributive property. That is the commutative property. Okay. This does, and this does not. Okay, that is not the distributive property. Again, that is the associative property, right? If you look inside the parentheses, there are different things inside the parentheses. How would you express 499 to find the products? That would be 500 times 5 minus 5, right? 500 minus 1 times 5. That is simplified. That is not. I need to distribute the negative to both of those. And the last one, ooh, this is tricky. Are these two like terms? 12xy and 3yx. Are they exactly the same? Not quite, but if we use the commutative property, we are allowed to rewrite this as xy as well. We're allowed to change the order within a term, and then now I can see that these are exactly the same. So it's 5x squared plus 9xy. Okay? So just be careful with a problem like that. And that was 1-7, the distributive property.